Good evening, everyone, or good afternoon, everyone. Please, if you're online, indicates that you're online. We are starting as soon as possible. If you're online, please indicate your presence that you're online. If you're online, please indicate your presence that you're online. All right, good evening, guys. How are you guys doing? Please, if you're online, indicate that you're online. Please, guys, indicate that you're online. We are starting now. Please indicate. Please indicate your presence. Please, if you're active, indicate your presence. We are starting as soon as possible. All right, guys. Good evening, everyone. Please, if you are active, indicate that you're active. Okay, we are going to be starting now so that as we continue, others might likely join the process. This class is a 4 hours marathon class. 4 hours. We will be having the first 1 hour, the first 2 hours class. Then we'll continue again the next 2 hours. All right. So everything we'll be discussing tonight will be on functions. For those of you who are in UNN, that will be having your exam in Math 104. You have to pay attention because everything I'm discussing tonight will be appearing in your exam. My name is EMI-BRAIN. For those of you who don't know me, this is our YouTube channel. We meet here often on live. All right. So for those of you who attend Imo State University, the course code is Math 102. While those of you who attend UNN, the course code is Math 104. The course content are just the same. They are just the same. So throughout this class, we're looking at function. We look at function. We look at the definition of function. Definition of function. We look at mapping function. Mapping function. Then from here, we proceeded to the types of function, types of function, types of mapping function, rather, types of mapping function. All right. Then also look at other types of function, other types of function. Then after this, we go into what we call the domain of a function, domain of a function, of a function. All right. Then after this, we move into limits, limits and continuity, continuity of a function, of a function. Then after this, we go into calculus. Calculus might not be tonight. Under calculus, we look at differentiation, differentiation, and integration, and integration. Then we look at the applications as well, the applications of calculus. When we have the turning point of a curve, point of inflection, maximum and minimum points, and so on and so forth. All right. So all of this we shall be discussing. Sorry. Throughout this class. So let's start with what is function. Okay, what is function? Now, when you hear the word function, what comes to your mind is f of x, right? F of x equals to y. All right. What comes to your mind is f of x equals to y. Are you there? Function is just like a type of relation that assign every element of a particular set called the domain to a unique element in other set called the codomain. Function is a set of rules that links two or more elements in different sets. Either now we have what we call the domain, the codomain, and the range. These are the three basic terms that are used in function. All right. So, like I said, function is a set of rules. Is a set of rules, or is a set of rules, yes, that assign or that link or that connect every element of a particular set that are called the domain to a unique or different element in other set called what? The codomain. That's called mapping function. Either. Now, generally, function can be represented as f of x. F of x simply means f is the function of x, and f of x represents y. Either. Like I said, in a function, we have some terms that are used to describe a function. Some terms that are used to describe a function. The first is called the domain. Number two is called the codomain. Number three is called the range. The range also means the word image. Please pay attention. We have what we call the domain, the codomain, and the range. The domain represents the independent variable. The codomain represents the dependent variable. Then the range represents the images. Now, when you hear the word the domain simply means independence. Independence. It means all set of input values that can describe a function is called what? Domain. I'm going to illustrate this using a diagram. A diagram to explain. We say we have three terms, right? We have the word domain, which means independent variable, which represents your x variable. We have the codomain that represents the dependent variable, which represents your y variable. We have the range that represents the image. Now, when I say domain, for instance, if I have this, I have a set A, and that set what? Set B. There is always a connection between set A and set B. Set A is called the domain. Set B is called what? The codomain. That set of rules that tends to assign every element in the domain to a unique or different element in the codomain is called what? It's called mapping what? Function. Are you there? So we call the domain the S variable, also called inputs, or set of input values. This is also called the independent variable. Independent what? Variable. We call the codomain or set of what? Y. And Y represents output, right? Output values. Also known as what? Dependent. Dependent. What describes a function is that we have what we call the inputs and we have what we call the outputs. It is the input that determines what? The output. It is the independent variable that determines what? Dependent what? Variable. Let's say we have a set A and set B. And we have some elements here, 1, 2, 3, and 4. And we have some elements here, let's say A, B, C, and D. If 1 is mapped to A, 2 is mapped to B, let's say 3 is mapped to D, and 4 is mapped to what? To C. We call this set of relationship mapping what? Function. So F is a function of S, meaning that what is connecting A, set A, to set B is this F of X, which can be represented in form of a function. Like I said, a function is described as F of S equals to Y. For example, if I have F of X equals to X plus what? 2. This simply means what? Y equals to X plus 2. Anytime you see F of X in mathematics, it simply means what? Function of X. And that function of X represents your dependent what? Variable. S represents your independent variable. Of course, if you look at this expression, it simply means that the value of Y depends on X. All right? So S is called independent. If S is 1, Y will be 1 plus 2. That will give us what? 3. If S is 2, Y is 4. If S is 3, Y is 5. If S is 4, Y is 6. So the value of our Y depends on what? On the value of X. So this is called function. Then representing a function in form of a diagram that shows the set of rules that connect them, we call the mapping what? Function. Am I communicating now? I can represent this using a diagram. That diagram that shows the relationship between the dependent and independent variable is what describes what we call the mapping what? Function. Now let's see a good example. I've given us an example here that if I have a set of rules that connects A to B, which is F of X, don't forget that F of X can be maybe a function of X, might be X plus 2 or S squared plus 5S plus anything. It can be polynomial. It can also be a rational function, right? It can be a function that has a square root. Okay? What this F of S just represents is a link. What is connecting set A and what? And set B. Now, look at this. If 1 is mapped to A, 2 is mapped to B, 3 is mapped to D, 4 is mapped to C. What do you notice here? Every element in this domain have a unique element in the codomain. This is called the codomain. This is called the domain. 1 is only mapped to A. 2 is only mapped to B. 3 is only mapped to D. 4 is only mapped to C. We call this type of mapping function one-to-one. One-to-one mapping function, which is also known as injective. Injective function. One-to-one. also called injective. One-to-one means every element in the domain have a unique element in the codomain. Every element in the domain is assigned to a particular element in the what? In the codomain. Am I communicating now? That's called one-to-one. So function can either be one-to-one, can be one-to-one, can be onto. Onto means every element in the codomain is assigned to at least one element in the domain. I'm coming to that aspect. It can also be constant, where every element in the codomain is assigned to a particular element. Sorry, every element rather in the domain is assigned to one element in the codomain. We call that constant mapping function. We can also have what we call the inverse mapping function. This is the case whereby the domain becomes the codomain and the codomain becomes what? The domain. It's called the inverse mapping function, whereby every element here, B, becomes what? Becomes A. Meaning, by the time we interchange their position, we have what we call the inverse mapping function. We call that what we call the composite or composition of mapping function. We are coming to all of this. All of these are the things that I'll be discussing in today's class. Then we have other types of function, like quadratic function, linear function, polynomial function, cubic function. We have what we call the rational function, and so many of them that I'm looking at in today's class. So follow me. Now listen. Let me give an illustration to explain something very important. Please help me to share the link to your classmates. Don't just be here learning alone. Share the link to them. Share the link, share the link, share the link, share the link. Let more people join. Share the link, share the link, share the link. Now listen. If we are given, I want to illustrate a mapping function. If we are given f of x equals to, let's say, we have here x plus 3. And the value of x is given as 0, 1, 2, 3. Let me stop here. And we are asked to analyze the function, the mapping function. We are given f of x to be given as x plus 3. And the value of our x, which is called the domain, is given as 0, 1, 2, 3. And the question says analyze the domain. All right? So what do we do here is to find our f of x. Don't forget that f of x simply means function of x, which is same as what? Y. F means function. X means independence. Y means dependence. So this can be read as function of x equals to y. So if the function of x is given as this, that means this, the whole of this represents my y, right? Okay. And x is given as 0, 1, 2 to 3. And we have to analyze. So let's analyze together. Here we have, let's call this set A and set what? Set B. This is called my domain. Domain is given as what? As 0, 1, 2, and 3, right? The codomain is what we are going to determine from this relationship. But we are told that the assignment that link this element, these two sets together, is f of x, which is equals to what? S plus what? 3. This is the assignment here. This is what is connecting set A, the domain, with what? With the codomain. That means I will use this assignment here, this relationship, to find my codomain, the maps. Now let's go. When the value of x is 0, here becomes 0 plus 3. It means I will have 3 here, right? When the value of x is 1, here becomes what? 1 plus 3. That will give us 4. When the value of x is 2, what is 2 plus 3? 5. When the value of x is 3, what is 3 plus 3? That will give us 6. That means 0 is mapped to 3, 1 is mapped to 4, 2 is mapped to 5, 3 is mapped to 6. We call this kind of mapping function one-to-one, one-to-one. Also called what? The injective. Also called injective. This is my domain. This becomes what? Our codomain. Our codomain. So this is called one-to-one or injective mapping function, whereby every element in the domain have an image in the codomain, have a unique image rather, a unique image. 0 is only mapped to 3, 1 is only mapped to 4, 2 is only mapped to 5, 3 is only mapped to 6. We call this one-to-one or injective mapping function. Am I communicating? Please, if you are following, indicate in the comment section. Just tell me you are following. Go ahead. Just tell me you are following. Go ahead. If you are following, indicate in the comment section. Okay. Now let's proceed. Please indicate in the comment section. So let's proceed. Let's finish up. Let's continue, guys. Now we have seen a good example of the mapping function. Right? Okay. Now let's proceed. Let's look at the types of mapping function. Types of mapping function. We have seen the first one, which is called the injective, right? The injective. Injective, this also called one-to-one, right? One-to-one mapping function. A good example is what we just saw now. One-to-one simply means every element in the domain is assigned to a unique element in the codomain, like we just saw. Number two, we have what we call the onto, the surjective. The surjective. This is called the onto mapping function. The onto mapping function, this is the mapping function whereby every element in the codomain is assigned to at least one element in the domain. I repeat again, every element in the codomain is assigned to at least one element in the domain. And also, the range of the mapping function must be equal to the codomain. For example, let me give an illustration. If I have this, and I have here is A, here is what? B. So I have here to be 0, 1, 2, and 3. If I have here as A, B, C, and D. Okay, let's say 0 is assigned here, all right? Then, let's say this is also assigned to this, all right? Then 2 is assigned to this. 3 is assigned to this. Let me remove this. Look at this. What do you notice here? Here I have my domain, right? I have my codomain. We define surjective as a mapping function whereby every element in the codomain is assigned to at least one. The word at least one means either 1 or 2 or 3. Example, A, an element of B, is assigned to 2 elements in what? In A. Are you there? We cannot call this one-to-one. One-to-one means that every element in the domain must have a unique element in the codomain, meaning 0 must be assigned to only one element in the codomain. Of course, if you look at this, 0 is only assigned to 3, 1 is only assigned to 4, 2 is only assigned to 5, 3 is only assigned to 6. So this is called one-to-one mapping function. But look at this. Every element in the codomain is assigned to at least one element in the domain. Are you there? Meaning A, element of B, is assigned to at least one. At least one means either 1 or 2 or 3. Meaning that this A, being an element of B, is mapped to what? 0, 1 element of what? Of A. Am I communicating here? So A is assigned to more than one element. And also, what defines surjective is that the image, the range, must be equal to the codomain. If the range is not equal to the codomain, it becomes an into function, into mapping function. I will explain. Look at this now. What is range? Range simply means the image of what? Of A in B. The image of A are simply what? A, B, and C. That means the range of this mapping function is what? A, B, C. If I have this here, let's say I have D, please pay attention. My codomain is A, B, C, D. But my range or my image is what? A, B, C. Why do we say D is not part of the image or range? The word image means range. D is not part of the range because D is not assigned to any element in the domain. So D is not part of the range. Am I communicating now? So range simply means the image. What are the image? What are the elements that are assigned from B to what? To A, which are what? A, B, and C. So these are the range. So what defines a surjective? Two things define a surjective. The first is that every element in the codomain must be assigned to at least one element in the domain. Number two is that the range of the mapping function must be equal to what? To the codomain. A good example is what we just saw now, right? Good. All the elements here is assigned to at least one, and also the range, which is our A, B, C, is equal to the codomain. What's our codomain? A, B, C. But peradventure, if I have D here, this definition here, if I have D here, this goes in alignment, right, with my definition that says that every element in the codomain must be assigned to at least one. But the range is not equal to the codomain. The range of this function is A, B, and C. But the codomain is what? A, B, C, and D. So I cannot call this an onto or surjective. This becomes what? An into mapping function. Into mapping function. Into is similar to that of what? Onto. But what differentiates into with onto is that in an into mapping function, the range is not equal to the codomain. But whenever the range is equal to the codomain, it becomes what? Onto or surjective. Okay, so let's proceed. Let's proceed. Now we have seen injective, we have seen surjective, we have seen into, right? Into mapping function is a kind of onto mapping function whereby every element in the codomain is assigned to at least one element in the domain, but the range of the function is not equal to what? The codomain. We call that what? An into mapping function. Some other person call it many to one, also called many to one. An into mapping function is also called what? Many to one mapping function. Into mapping function is also called many to one map. But don't forget, what differentiates an into from onto is that in an into mapping function, the range is not equal to the codomain, but in an onto mapping function, the range is equal to the codomain. Now, the next one I want us to look at okay, the next we look at now is called bijective. What is the bijective function? The word bi means two. Bijective simply means is a function that is both one-to-one and onto at the same time. That is both one-to-one and onto. Meaning when a function is both injective, when a function is both injective and bijective, injective and surjective, we call such function a bijective function. A bijective function. Okay, I will explain. A good example of bijective function is see this. Don't forget that we say this is called one-to-one mapping function. One-to-one means every element in the domain is assigned to at least one element in the codomain, right? Then we also say that surjective is that every element in the codomain is assigned to at least one. The word at least one means either it's assigned to one or two or more than, right? Look at this now. 0 is assigned to only 3. 1 is assigned to only 4. 2, only 5. 3, only 6. Fourth, this is called what? Injective. This is also called surjective because 3 is assigned to at least 1. At least 1 means either 1 or 2. 4 is assigned to what? Only what? 1. 5, only 2. 6, only 3. At least 1 means either 1 or 2 or 3 or 4. So we call this type of mapping function surjective. So that means when a mapping function is both injective and surjective, it's called what? A bijective function. A good example is what we just saw. Why do we say this is also surjective? The range of this function, what's the range here? The range is 3, 4, 5, and 6. What's the codomain? 3, 4, 5, and 6. So the range and the codomain are both equal. So this is also called the range, also called surjective, right? Because the range and the codomain are equal, are also called one-to-one and surjective. So it's called a bijective what? Mapping function. Now let's see. Let's solve one or two problems from past question. Let's solve one or two problems from past question. Then we proceed from there. We are asked to consider this mapping. Consider this mapping. F is such that A is mapped to B, where A is given as A, B, C. B is given as S, Y, Z, U, and V. And we are given a diagram. The diagram is this. Here we have our A, we have our B, and A we have A, B, and C. Here we have X, Y, Z, U, and V. A is mapped to X, B is mapped to Y, C is mapped to V. And we are asked to find the following. Find, number 1, the domain. Number 2, the codomain. Number 3, the range. All right. Okay. Okay, let's proceed. To find a domain is very simple. One says find a domain. Our domain is simply set of all values of A, B, C. It was even given here, which is A, B, and C. Our codomain is X, Y, Z, U, V, right? X, Y, Z, U, and V. Then the next one is called the range. The range. The range simply means the image. What are the range? All the elements that are linked from A to B are what? X, Y, and what? And Z, right? In the codomain, they are X, Y, and Z. So our range is what? X, Y, and what? And Z. That is just all. That is just how simple this can be. And what kind of mapping is this? This is called one-to-one because every element in the domain is assigned to a unique element in the codomain. The type is called one-to-one, also called what? Injective. Also called injective. Also called injective. All right, so let's proceed. Let's proceed. Let's proceed. Let's see another question. We have another question here, another past question. Another past question. This question says that if f of x equals to 2x plus 4, we also find, this is very simple, number 1, f of 1, number 2, f of 2, number 3, f of 4, number 4, then we have f of a plus b, f of a plus b. Okay, let's solve this together. Solution to this is that we are given, right, that our f of x is equals to 2x plus 4. What we have to do here, number 1 says find f of 1. F of 1, it simply means when you compare, right, when you compare this with this, it means our x is 1. It means that in this function, anywhere we see x, we put 1. And that will give us what here? 2 times 1 plus 4. And that will give us 6, right? Number 2 says find f of what? F of 2. And f of 2 will give us what here? 2 times, what's our 2? 2 times 2 plus 4. This will give us what here? 2 times 2 is 4 plus 4. That will give us 8. The third one will be what? The f of 4. That should be 2 multiplied with 4 plus 4. This will give us what here? 8 plus 4, right? And that will give us 12. That will give us 12. The fourth says f of a plus b. The same way we solve for all, we're going to solve for this. What we do here, it simply means in this function, I will replace my x with what? A plus b. That will give us 2 times a plus b plus 4. So what do we do here? What we just did there was substitute the value of x as what? As a plus b. So I'm going to expand this as 2 times a, that will give us what here? 2a plus 2b plus 4. All right? Okay, we can actually factor out this. What is common here becomes 2 in bracket, a plus b plus what? 2. All right? So this is the final answer for this. Okay, so you can take note of this. Let's proceed. Let's proceed. Now, you have to note that all functions are mapping. All functions are mapping, but not all mappings are what? Functions. I'm going to explain. All functions are mapping, but not all mappings are what? Function. Note, all functions are mapping, but not all mappings are what? Are functions. This is a common exam question. You'll be given a diagram and you'll be asked to identify if there are mapping functions. All right. Now we said all functions are mapped, but not all mappings are functions. But not all mappings, not all connections are what functions. A good example, let me give us an illustration. Look at this diagram. If I have A, if I have B, let's say there's a relationship here, which is f of x, and I have here to be A, B, C, and D. I have 1, 2, 3, and 4. All right. Okay. Let's say if A is actually assigned to this, B is assigned to this. Let's say C is also assigned to this. All right. So this is assigned to this, and this is assigned to this. All right. Let me add E. Let me add E. And if E is assigned to 4, it is a mapping function. All functions are mapping, but not all mappings are functions. Can we say this is the mapping function? Is this a function? Is this a function? Of course, this is a mapping, but is it a function? Not all mappings are what function. This is not a function. This is not a function because if you look at this very well, okay. Okay, this is a mapping function, sorry, because every element in the what? In the codomain is assigned to at least one element. Is that not? It's the mapping function, rather. Every element in the codomain, this is our domain. This is what? Our codomain. What do you notice here? A is assigned to 1, B is assigned to 2, C is assigned to what? To 2. Is that clear? So D is assigned to what? 3, E is assigned to 4. This is a mapping function. Yes, a mapping function because every element in the codomain is assigned to at least 1, right? We call this mapping function surjective. Don't forget, this is called surjective. This is called surjective. Now, let me ask a question. Let's say if I remove this 4 from here, all right, and we have an element called E. Can we say this is a mapping function? This is not a mapping function. This is not a mapping function because E, an element of what of A, is not assigned to any element in what? In B. What describes a mapping function is that every element in the domain must have an image, in the codomain. If any element here does not have any link or any relationship or any assignment with any element in the codomain, that mapping function does not exist. It's not a mapping function. So E cannot stand alone. Are you there? So how do we identify this? There's something I always use to identify a mapping function. I use what called son and father relationship. Son and father what? Relationship. Are you there? Look at the domain as sons. Look at the codomain as what? As father. Are you there? A son has a father. A son has a father. A son has the same father. It's possible. Two sons can have the same father, right? A son has a father, but a son cannot stay without having a father. So he cannot exist here without having any assignment here. So this is not a mapping function. But by the time we take off this E, this is a mapping function. Am I communicating now? So whenever any element in the domain does not have any assignment or any link with any element in the codomain, it ceases not to be. It cannot be a mapping function. The rule of mapping function is that every element in the domain must have an image in the codomain. So from what we just saw now, this example is a mapping function because all the elements here are assigned here. So, and we have seen that sons have their unique what? Fathers. All right. So let's see another diagram. Let's see another diagram. Please take note of this. If I have a diagram like this, and I have a diagram here, let me repeat. Okay, A, B, C, and D. All right, and let's say we have 1, 2, 3, and 4. Okay, so let's say this is assigned to this. All right, this is assigned to this. Okay, this is assigned to this. This is assigned to this. Then this is assigned to this. Look at this diagram. Is this a mapping function? Please, if you are active, indicate that you are active. Is this a mapping function? Definitely no. This is not a mapping function, right? This is not a mapping function. The domain and the codomain. The codomain. Look at this. Like I said, we are using a son and a father relationship, right? To illustrate what a function is. Like I said, all functions are mapping, right? But not all mappings are functions. So is this a function? This is a mapping, but is it a function? It's not a mapping function, or it's not a function, because if you look at this, a son being C, C is assigned to two elements in the word codomain. A son cannot claim two fathers. It is not possible. But two sons can claim a father. This is a right alignment. This is right alignment. But C being assigned to 2 and 4 is wrong. So a son, C cannot assign itself to more than one element in the codomain. Is not possible. But D is assigned to 3, correct. So what disqualified this as being a mapping function is because C, element of A, is assigned to 2 elements in B, which are what, 2 and 4. So we are saying that a son being C cannot claim 2 fathers. All right, good. All right, but by the time we remove this, let me take off this line from here and let's analyze this together. Can we say this is a mapping function? Yes, it's a mapping function now because A and B, element of A, right, is assigned to one element in what? In B. So that means 2 sons can claim a father. Either. So each of these sons, they have their unique father. But a father can decide not to have a son. So 4 itself, not being assigned to any element in the domain, does not disqualify this diagram as being a mapping function. Because a father can decide not to have a child or a son or a daughter or anything. This can also be a child and father relationship. So yeah, we are saying that 4 being an element of what? Of B is not assigned to any element in A does not disqualify this one being a mapping function. This is a good example of a mapping function. Don't forget that we say that this is called an into mapping function. It's called an into. Other people call it many to one mapping function. This is not onto. Onto is when your codomain is equal to your range. The codomain here is 1, 2, 3, 4. The range is 1, 2, 3. So they are not equal. So that means that it is not onto, but it's called what? Into. Are you there? All right. So this is just how to identify a mapping function. Always use a son, or you can use a child, and what? Father relationship. Anyone you want to use to illustrate mapping function. Okay. Now the next is for us to look at the next types of mapping function, which is called the constant mapping function. Constant mapping function. Constant mapping function. If I have a diagram of this kind, I have A, I have B, I have 1, 2, 3, 4, and here is A, B, C, D. Don't forget we say this is called our domain, right? Domain, and this is called the codomain. All right, and if every element here are all assigned to a particular element, we call this a constant. This is a constant mapping function. This is a constant mapping function in the sense that every element in the domain is assigned to one particular element in the codomain. Like this is like saying this is a this we have sons, right? Sons and what and fathers. Is that clear? Sons and fathers. All right. What do you notice here? Every element here have a particular father, which is C. But these fathers they can decide not to have what a son or a child. So this is also a mapping function. But we call this what constant. Constant mapping function. Constant mapping function. All right. So in essence, to illustrate this simply means our f of 1 equals to C, f of 2 equals to C, f of 3 is equals to C, f of 4 is equals to C. So in general way of expressing a constant mapping function is simply f of x equals to what? To C, where C represents what? Constant. Are we there, somebody? So when you see f of x equals to C, like what we just saw now, it simply means f of x is constant, meaning that f of 1 is C, f of 2 is C, f of 3 is C, f of 4 is C. We call this a constant mapping function. The next one is called the composition of mapping function. Composite mapping function. Please, if you are following, indicate you are following. Okay. Composition of mapping function. Composition of mapping function. Also called composite. Composite function. Alright. Composite function. Okay, so when you do a composite mapping function, this is a situation whereby the codomain of a function becomes the domain of another function. It's a situation whereby the codomain of a function becomes the domain of another function. For example, if I have three functions, I have A and I have another function called B, I have another function called C. If yes, A, B, C, and D, I have E, F, G, and H, I, J, K, and L. If A is mapped to E, let's say A is mapped to E and E is mapped to J, if B is mapped to F and F is mapped to I, okay, I'm just assuming, then let's say C is mapped to G, D is mapped to K, D is mapped to H, and H is mapped to L. What do you notice here? This is my domain, right? This is what? My codomain. This also becomes our codomain. But this is the codomain of this. Between these two, let's say if I have my f of x here, and yes for g of x, then what is connecting A and B is f of x. What's connecting B and C is what? G of x. Either. What you notice here is that between these two, this is the domain, this is the codomain. Between these two, this is my domain, this is what the codomain. So composition or composite simply means is a situation whereby the codomain of a function, of a given function rather, become the domain of another function, where the codomain of this function becomes the domain of another function. It becomes what? Composition of a function. And we read this, we represent this as g of f of x. G of f of x is a reverse reading g of f of x, meaning g of f of what? Of x, which is also same as what? G of, okay, g of, sorry, let me come this way, of f of x, g of f of x, g of f of x. Are you there? If I have my f of x here and this is my g of x, are you there? So to represent this in statements or mathematically using composite mapping function, simply mean gov s. Gov x means g of f of x, g of f of x, which is same as what? G of f of x. So if the relationship here between A and B is g of x and between B and C is f, it means the reverse will not be the case. f of g of x, which is called fork x. But for this, since I have f of x, I have g of x, it simply means that the compressed form of this diagram is what? G of f of x. Am I communicating here? Okay, let's see what we can do. This implies that g of f of x simply means g of f of x in this case, right? In this form. So if I have this, if I have fork f of g of x, this can be written as what? F of what? G of x. But this diagram is the reverse of this, right? Because it's for this diagram, for this, what will here will be g of x, what will here about f of x. So anytime you are given a composite function where we have f of x here, g of x, the expression for such diagram is gof x, which is being pronounced as g of f of x, g of f of x, g of f of x. Therefore, 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 g of f of x, this f of x here, we're dealing with a. Let's deal with the first one, a. Therefore, g of a is equals to g of a is equals to j, because what connects a, okay, a and b is what? From a to e to g, right? So that means my g of f of x, or g of a, g of a is what? Is j. G of b will be what? I. G of b is I. Then g of c is equals to k. Then g of d will be equals to what? L. Equals to L. This is how to represent composition of mapping function. G of a is j. G of b is I. G of c is k. G of d is what? Is L. Just like that. Okay, let's see a good example under composition of mapping function. Let's see a good example. Please, if you are following, indicate that you are following. Okay, let's see a good example of composition of mapping function. All right. We are given a function here. We are given a function here. All right. We are given a function giving f of x, giving f of x to be equals to 2x minus 1 with domain. The domain is 1, 2, 3, and 4. And g of x equals to x squared with domain of x. All right, with domain of x. And we also find the following. Find number one. Okay, let me write it down. Number one, g of f of 1. Number 2, g of f of 2, right? Number 3, g of f of 3. Okay, let's look at this diagram first. Let's analyze our diagram, then we'll proceed from there. We are told that f of s is 2s minus 1 with domain and g of x. Domain is this. Already we are given our domain, right? Let's bring our domain. Let me call here A. Let's call here point A. Our domain is 1, 2, 3, 4. 1, 2, 3, and 4, right? Okay. It's 1, 2, 3, and 4. Alright, so here we have the first function. The first function is given as what? F of x, right? F of x. Let's call here what? Let's call here b. Alright. Then we have another function connecting. Another function, which is what? This is our f of x, right? Our f of x. We have our g of x, which is equals to s squared. S squared. Let's call it c. Please pay attention. Okay. Sorry, let me just get the diagram. Alright. We are told that f of s is 2s minus 1. 2s minus 1, right? While g of s is s squared. So between a and b, the function there is f of s. Between b and c, the function there is what? Is s squared. Okay. So what we do is to find the codomain here, right? Let's find b. The domain is given at 1, 2, 3, 4. Alright? So it means that to find my b, set b, I will use my f of x. And f of x is given as 2x minus 1. Don't forget. So for f of 1, that will give me 2 times 1 minus 1, right? The answer is 1. Is that clear? So here I have 1 here. So for f of what? 2. F of 2, we have 2 times 2 minus 1. Is that clear? And that will give us what here? 4 minus 1, we have 3. Here we have 3. For f of 3, that will give us f of 3 equals to 2 times 3 minus 1. That will give us 6 minus 1, right? And that is 5. For f of 4, that will give us 2 times 4 minus 1. 2 times 4 is 8 minus 1. That will give us 7. Okay, we are done with this. We are done. Then we are told that between b and c, the second function and g of x equals to s squared. The domain of x means the same domain of x. Are you there? So, which is this? It means I will use this value become the domain to find my g of x. So here we have g of x s squared. So 1 squared is 1, right? Okay, let's go. 3 squared is 9, right? 5 squared is what? 25. 7 squared is what? 49. What does that imply? 1 is mapped to this. 1 is mapped to this. 2 is mapped to 3, right? Is that clear? So 3 is mapped to 9. 3 is mapped to 5. 5 is mapped to 5. 4 to 7. 7 to what? 49. This is called the composite mapping function. What does this mean? What does this mean? It simply means that f of g, g rather, not f, g of f of 1, right? G of f of 1 is equal to 1, right? Number 1. Number 2, g of f of 2 is equals to what? 9. Number 3, g of f of 3 is equals to what? 25. Number 4 is g of what? G of f of 4 is equals to 49. This is just the answer. This is just the answer. Okay, but I'm going to use another means to calculate the mapping function for composite mapping function without the use of diagram. All right. without the use of diagram. Let's see how we can get it without the use of diagram. Okay, please take note of this. Let's see. Now let's pay attention. Let's take note of this question. We are asked to find f of x equals to, we are given f of x equals to 2x minus 1 with this domain, and g of x is given as this. And we also find the whole of this, and we have seen our answers. But let's see how we can attempt this with that diagram, because most of you that attends UNN, you don't need to draw, you just need to put in the values, all right? So let's look at this together. I call this method analytical method, all right? I call that method analytical. That's for me, analytical method, all right? Which I say that if we are given our g of f of x, right? I say this is same as what? G of what? F of x. Is that clear? But we are given, let's analyze what we are given. We are given our f of x, right? To be equals to 2x minus 1, and g of x to be equals to x squared. The first thing we are asked to find is what? Is g of f of 1. G of f of 1. Okay, look at this, someone. If we are saying that g of f of x is same as g bracket f of x, it simply means that this can be written as what? G of f of 1. Am I communicating? If this is same as this, so I can rewrite this as g of what? F of 1. Am I communicating here? So if this is true, so the first thing we need to do, there's a word called BODMAS. In BODMAS, the first thing is the bracket. It means I have to evaluate what is in the bracket first. I have to find my f of 1 first. Am I communicating? So to find f of 1, evaluating, please take note, f of 1, right? F of 1, to find f of 1, I'm going to use my f of x to find f of 1. Meaning that in my f of x, anywhere I see x, I'll put 1. That goes 2 times 1, right? Minus 1. Is that clear? And that will give us what? 2 times 1 is what? 2. 2 minus 1 is what? Is still 1. So then my f of 1 is this. What does that imply? That simply implies that my g of f of 1, right? Is that clear? Is now equals to what? G of, what we say is our f of 1. We solve 1, Abi, is now equals to 1. Am I communicating here? Now, the next is to find g of 1. How do we find g of 1? I will use my g of x. And what's that g of x? Is x squared. Here becomes what here? 1 all squared. What is 1 all squared? Is 1. Am I communicating? So are we not saying that g of f of 1 is equals to what? 1. With the use of diagram, we got 1. With the use of analytical method, we see solve as what? As 1. Now let's solve. Let's find g of f of 2. Please take note, if you didn't get this first one, try to get the second one. Let's solve for g of f of 2. Let's solve for this. To solve for g of f of 2, we can rewrite this as, don't forget that we say that g of f of x is same as g of fx, right? So this is same as what? G of f of 2 equals g of f of what here? 2. So what we do first is to evaluate, right? Evaluating, I have to find the bracket first. Evaluating f of what? 2. F of 2, to find f of 2, I will use my f of x. You know, I have f of x and g of x. So I'm looking for f of 2. It means I have to use my f of x to find f of 2. So that means here becomes what? 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is what? Is 3. Therefore, this means that g of what? of f of 2, right? Which is now equals to what? G of what did we solve at f of 2? We got 3. Is that not? Now, what we do further is to find g of 3. Exactly. To find g of 3, I'll need to use my g of x. And that will give us what here? G of x is x squared. Here becomes my x. So we have 3 all squared. What is 3 squared? It's 9. The same answer. Are you guys following up? Let's solve for g of f of 3. G of f of 3. G of f of 3. For g of f of 3, this can be expressed as what? G of f of 3. Am I communicating? So the first is to evaluate, right? Evaluating f of what? 3. To find f of 3, that will give us, I'm going to use what to find f of 3? In the comment section, who can tell me? I'm going to use my f of x, right? Meaning 2 times. In my f of x, anywhere I see x, I'll put what? 3. So 2 times 3 minus 1. And that will give us 2 times 3 is 6. What is 6 minus 1? We have 5. So that means that therefore, g of f of 3 is equals to what? G of what? F of 3, we have solved as 5, right? So to solve for g of 5, what do we use? We use our g of x. Meaning here becomes what again? 5 squared. And what's 5 squared? 25, which is the same answer we got here. Now the next question is simply g of the next question is simply g of f of what? 4. I'm going to leave this for you to solve as your assignment or your class exercise. Please solve this for me in the comment section and send in the answer to this g of f of 4. Now, don't forget that if we are to find this, note that for g of f of x, we say the result is what? G of what? Note that g of f of x is equals to what? G of fx, right? Also, you have to also note that fog f of g of x is also equals to what? F of g of x. F of g of x. So fog x is equals to what? F of g of x. You have to take note of that. Very important. All right. Under composite mapping function. Okay, let's solve a problem. Let's solve a problem. Let's solve a problem. Are we ready? Let's solve a problem. After this, we go into inverse. Then we are done. We now move into the domain of functions. All right, the domain of functions. Let's look at this example. Okay, we are given f of x to be equals to x squared and g of x to be equals to x plus 1. Then question say find number 1 fog 2, number 2 fog fork 3, number 3, fork x, number 4, fork, golf rather, golf x. Let's solve this question together. This under composite function. We are told that f of x is x squared and g of x is x plus 1, and we are also finding our fork 2. The first one said find fork 2. Don't forget that this can be expressed as what? We can express this as fork 2 can be expressed as f g of 2. Don't forget, right? We analyze this together. Fork 2 is same as what? F g of 2. So what do we do is to evaluate g of 2. We have to evaluating our g of 2. To find g of 2, which of these functions are we going to use? Definitely I will use g of x to find g of 2. So that means in my g of x, anywhere I see x, I'll put 2. And that'll give us what? 2 plus 1, right? We have 2 plus 1. The result here is 3. Therefore, this simply means that f of g of 2 is equals to f of, what do we solve as g of 2? The result is 3. So what do we solve? We have to solve for that, right? We have to find f of 3. F of 3, I will use f of x, right? It means that in f of x, I'm going to substitute my x as 3. So that will give us 3 squared. The result becomes what? 9. Okay, we are done with this. Number 2. On your own, please attempt this for me. The same way we solve this, attempt this, all right? Then drop the answer in the comment section. Let's solve number 3. Number 3 says f of g of x. F of g of x can be expressed as f of g of x. Don't forget, f of g of x, right? For x is same as for f of g of x under composite mapping function. So what do we do here? Already, there's no need of evaluating g of x, or we can just say recall that g of x is already given as what? As x plus 1, right? G of x, this g of x here is already given as x plus 1. We don't have a number here, we are using a variable. We are told we have to find for x, not for 1 or for 2, for 3, for x, which can be represented as what? F of g of x. F g of x in bracket is given as what? X plus 1. So that means that this expression becomes what? F of what? G of x becomes our f of our g of x. We are told is what? X plus 1, right? X plus 1. So what do we do next is to find our f of x plus 1. What will I use to find f of x plus 1? I'm going to use my f of x, right? Meaning I will substitute the value of my x as what? X plus 1. So here becomes what? X plus 1 all what? All squared. Yes, x plus 1 all squared. I'll repeat again. For x is f of g of x. G of x we know was given as x plus 1. So here becomes, this expression becomes for x equals to f of our g of x is x plus 1. So I'm looking for f of x plus 1. And we use f of x, which is x squared. So that means my x now becomes my x plus 1. It means that in the f of x, anywhere we see x, I will represent that x as what? X plus 1, then all squared. Am I communicating now? By the time we expand this should give us x squared plus 2x plus 1. Of course, yes. By the time we expand this, we're going to have x squared plus 2x plus 1. Please do the expansion for me. Or let me just show us the expansion for those that might be doubting. Take the expansion. Let's solve this. Let's expand this. Let's expand x plus 1 or squared, which is same as s plus 1 in how many places? In 2 places. S plus 1, right? Okay. S times x is s squared. S times 1 is x. 1 times x is x. 1 times 1 is 1. So here becomes x squared plus x becomes 2x plus 1. So the expansion here is still the same thing as this. Okay, so take note. Now the fourth one says find the fourth one says find the fourth question says we should find, let's solve it together. We have to find gof x. Gof x. Gof x is same as what? G of f of x. The same pattern we use in solving number 3 will be used in solving number 4. Already we are giving, recall, we are giving f of x, right? Our f of x is given as what? As s squared, right? S squared. So what we do is to substitute the value of f of x here as s squared, right? Therefore, here becomes gof x equals to g of our f of x is what? Is s squared. Now, what we do next is to find g of s squared by using our g of x, right? I will use g of x to evaluate this. Is that clear? Therefore, this becomes what? Let's go. Our g of s becomes, it means that in my g of x, anywhere I see s, I'll put what? S squared. Here becomes what? My x is s squared, right? So let's go. S squared plus 1. Final answer. S squared plus 1. S squared plus 1. Final answer. So we are done with this. Let's look at what we call the inverse mapping function. The inverse mapping function. The inverse mapping function. Please, if you are following, indicate in the comment section that you are following. If you have any question, you can indicate in the comment section. If you have any past questions, any question you want us to solve together, you can indicate it in the comment section. Please indicate them in the comment section. All right, it will really help us to move forward. Am I communicating? So let's look at inverse now. Inverse mapping function. I've defined inverse already. Inverse mapping function. I've defined inverse already. When you do what inverse mapping function is a mapping function whereby the domain becomes the codomain of a function. The domain becomes what? The codomain. Are you there? While the codomain becomes what? The domain. When we interchange them, it becomes the inverse. A good example is this. If I have this, I have A, and A is A, B, C, and D. And I have B, yeah? B is 1, 2, 3, and 4. Alright, and A is mapped to 1, B is mapped to 2, C is mapped to 3, D is mapped to what? This. And the assignment between A and B is f of x. Are you there? Okay. So how do we have our inverse? Inverse becomes the reverse. B will be here. Then here I'm going to have what as what? As A. Then the assignment becomes f of x. F of x inverse. F of x inverse. F of x inverse. Inverse here does not mean 1 over f. No. Alright? Does not mean 1 over x like we all know in indices. That's not the same in same language. Alright? It just means an interchange. That it means that whenever the codomain becomes the domain and the domain becomes what? The codomain. It's called inverse mapping function. So our B remains our 1, 2, 3, and 4. A remains A, B, C, and D. So it means that this is still assigned to this assigned to this, assigned to this assigned to this. Alright, so this is called an inverse of this. You have to note that inverse mapping function inverse mapping function is only possible in an in 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 a one-to-one mapping function or injective, right? Injective. Injective what? Mapping function. Mapping function. Inverse mapping function is only possible in a one-to-one mapping function or in an injective. We cannot have an inverse in an onto mapping function. Imagine if I have an inverse in onto, it will not be a function again. It will be a mapping function again. All right. So inverse is only possible in one-to-one. It's not possible in constant. It's not possible in composite. It's not possible in into. In any other type, it's only possible in injective or one-to-one mapping function. Now let's see an example. Let's solve some problems under this. All right. Please take note of this. Okay. Okay. Let's proceed further. All right. If we are given f of x is equals to, let me get a function I can work with. 2x minus 7. 2x minus 7. We are also find the inverse of this. Find the inverse of f of x. Also means find f inverse, right? Of x. Inverse of this. This means find the inverse of x. Am I communicating? So solution to this is that I have to recall we are giving, or bring out that we are giving our f of x, which is equals to 2x minus 7. But recall that we say that f of x from the beginning is equals to y. Don't forget, f of x represents y. F of x simply means the function of independent variable equals to dependent variable. Y represents dependent variable, right? So if f of x equals to y, this becomes what? Y equals to what? 2x minus 7. Now what do we do is I have to make my x a subject of the formula. I'll make x subject of the formula. Please take note. Meaning I'll make my x to stand alone as the subject of the formula. Please take note. Okay. If I'm to achieve that, I will move this minus 7 to this side. Then I will keep this 2x here. Or I can say add plus 7. By the time I add 7 here and add 7 here, here will be y plus 7, here will be 2x. Am I communicating? Or just make our x subject, or move this minus 7 to this side. Is that clear? Okay. So when we do that, what will be left here will be 2x, right? 2x equals to, here we have what here? Y plus 7. Okay. You know, our aim is to make s a subject of the formula. So I have to divide, right? I will divide both sides by 2. That will give us 2x equals to y plus 7 over 2 over 2. This can go. We have x equals to y plus 7 over 2. Therefore, our f inverse of x becomes, when you achieve this, on this side, anywhere you see y, replace that y with what? With x. Am I communicating? The inverse of x, the inverse of independent variable, is when we interchange. Don't forget, we interchange the domain with what? With the codomain. Here becomes what? Here becomes x plus what? 7 over 2. This is just the final answer. This is the final answer. Let's see other examples. All right. Let's see other examples. Under inverse. Please, if you are following, indicate that you are following. If you are following, indicate that you are following. Let's get another example. Wow. We are rounding up already on this aspect. I just want us to get more examples on inverse, all right? Then we can proceed further. Okay, just excuse me. Let me just get question. We're going to solve now. Okay, let's look at this example. Under rational function, if we are given, let me end on this. Example 2, under inverse. Here we are given f of x equals to 5 divided by x minus 2. Find f inverse of x. Okay, let's look at this. The same thing, just recall that f of x is equals to y. So I will replace this with my y. Here becomes y equals to 5 over x minus 2. This is over 1. So what we do here is to cross multiply, right? We cross multiply. This will give us 5 times 1. Okay, here we're going to have here as y in brackets x minus 2, right? Okay, equals to 5 times 1. Okay, here we have y times this, then 5 times 1. Am I communicating? So our aim is to make our x as a subject of the formula. So what do we do here is to expand. Have to expand this. Y times x is yx or xy, minus y times 2 is minus 2y equals to 5. So our job is to make our x a subject. So what we do here is I have to move this to the other side, right? I will make my x as a make x subject, make x subject of the formula. So that will give us here, we have our sy equals, we have 5 here, right? 5, when we move minus 2y to the other side, it becomes plus what? 2y. So the next is to divide both sides, or divide 2 by y. So I'm going to have here sy over y equals to 5 plus 2y over y. Y can go with y here, so we have x equals to 5 plus 2y over y. So therefore, what will be our inverse of x? Inverse of x becomes 5 plus, on this side, I will replace my y with x, right? Here becomes 5 plus 2x over what? Over x. Final answer. Final answer. That's okay. Let's see one more example. Let's see one more example. Okay, I think this is a past question, and we are told that we are given. We have now a past question here. Past question. We have a past question that says find the inverse of f of x. Find the inverse of f of x equals to 2x plus 3. This is very simple. 2x plus 3. The same thing, we need to recall that f of x is equals to y. Here becomes y equals to 2x plus 3. So what we do here is to make our x a subject of the formula, right? So what do we do here? I can say subtract 3 from both sides. Or I will just move this to this side, right? So we make x subject of the formula. That will give us what? 2x equals to y minus 3, right? When you move this here, this becomes y minus 3. This sign here is plus, right? Because minus, or we can just say subtract minus 3 from both sides. Is that clear? Are you there? Okay, so if we achieve that, that will give us 2x equals to y minus 3. So the next is to divide both sides by what? By 2. By what? By 2. 2 can go with 2. We are left with what? X equals to y minus 3 over 2. Therefore, our f inverse of x becomes x minus 3. I will replace my y with x. There becomes x minus 3 divided by 2. Final answer, x minus 3 divided by 2. Okay. So let's see another example. Then we move into something else. I think we have seen how to find inverse of a mapping function. Another example. Another example. A good example we have here says, find the inverse of this. We are told that f of x equals to f of x equals to x minus 1. Okay, sorry. X minus 1 divided by x plus 2. X plus 2. Find f inverse of x. Okay. Like I said before now, that f inverse of x is not same as 1 over f of x. This is not it. If it is same, it means I will just turn this over, right? But it's not same as that. So you have to take note, okay? So what we do here is to recall that f of x is equals to y. So we have to replace this with y. It becomes y equals to x minus 1 divided by x plus 2. So the next is to cross multiply, right? We cross multiply. That will give us x minus 1 times 1 is x minus 1 equals to y times x plus 2. So here we have x minus 1. We're going to expand this. Y times x is sy. Y times 2 is 2y. Don't forget that our aim is to make our x a subject of the formula. So I have my x here, also have x here. So this two becomes like terms. So I'll collect like term because we want to make s to stand alone as the subject of the formula. So what we have to do is to bring all the terms that have x together. So it means I'll move this to this side, then move it to this side. When you move this to this side, here becomes, let's collect like terms. Collect like terms. Here becomes x minus xy. X minus xy. Am I communicating? X minus, when you move this here, becomes x minus xy. When you move this minus 1 to this, if I'm to move this here, what is remaining here is what is 2y, right? So when you move your plus minus 1 across, it becomes plus 1. So here becomes 2y plus 1. Am I communicating? Equals to 2y plus 1. Between these, what is common is x, because we are looking for x, right? So here we have x, we have 1 minus y, okay? 1 minus y equals to 2y plus 1. Now the next is to divide both sides by 1 minus y. 1 minus y. I will divide both sides by 1 minus y. And that will give us what here? X in bracket 1 minus y equals to 2y plus 1 over 1 minus y over 1 minus y. This can go, we are left with x equals to 2y plus 1 over 1 minus y. Therefore, our f inverse of x, don't forget, becomes, I'm going to interchange my y to become x, right? It becomes 2x plus 1 divided by 1 minus x. Final answer, 2x plus 1, okay, divided by that. Okay. All right, we're going to stop here for now, then proceed some other time. Stop here for now and proceed some other time. So this is our final answer there. We'll stop here. Our next topic should be, we are meant to have, our next class should be by 8 p.m. Right? 8 p.m. So I'll pause now. I'll pause. Then by 8 p.m. we continue again by 8 p.m. All right? By 8 p.m. we shall look at the domain of a function. The domain of a function. By 8 p.m. we look at the domain of a function. The domain of a function, right? Domain of a function. So we have been able to discuss what is a function, what are mapping functions, right? And we have seen the types of mapping function. Don't forget that we have other types of function, like the polynomial function. We have the linear function, the quadratic function. We have the rational function, right? And we have other functions, the cubic function, the logarithm function, the exponential function, the sine and cosine function. Am I communicating? These are other types of function. Please take note. Okay, so we'll continue our next class by 8 p.m. on domain of function. Then once we are done with domain, we're now going to limit and continuity. I'm going to use like 30 minutes to explain domain of a function, then give some examples. Then in the next 1 hour 30 minutes, we'll focus on how to find limits and continuity, how a function behaves as s approaches a certain value. We'll look at that in the next class from 8 p.m. So don't miss that class by 8 p.m. Then by tomorrow, we go into calculus. Okay, we're going to calculus, integration, differentiation, maximum and minimum points, and all that. Thank you so much for staying. Please ensure you save this video. After that, you can go back and watch. With this many examples here, we looked at many examples. Share the link to your classmates. Let them join us by 8 p.m. Don't just be here alone. Share the link. Let them join. So the next topic will be on domain of a function. Domain of a function. Thank you so much for your time. I'm grateful. All right, guys. See you in my next class.